Good evening, Srijita.
Good evening, sir.
For physics class, how many members they started? How many members they logged in, ma?
There were only two.
Okay, I think so. Javian, you only.
Yes, sir.
So remaining all they may be left. So they are doing home preparation because our exams are very near, na? Okay. Anyway, so today we are going to discuss about here. So hydrocarbons. Today we are going to discuss about here hydrocarbons. Hydrocarbons also it's very important chapter here. So based on this one also in NEET level and MSET level and all, they're asking some of the questions here. Actually, it is having more weightage. Okay. The problem is what happened means here hydrocarbons, haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, ketones, carboxylic acids. Okay, and amines. All these chapters are one is interlinked to another one. Okay, all these chapters are one is interlinked to another one. So we can find out some named reaction according to that one. Named reaction at all, we can study under the some separately chapter wise we are going to be studying. But conversions and at all means we can't say from where we can start, where we are going to be end here. Okay, so how they're asking the questions, the examination part is based on the conversion part. Okay, first of all, let us see what are the preparations and properties are there. Okay, and what are the chemical properties of the hydrocarbons and all it is there. So first of all, what is mean by the hydrocarbon? So what is the hydrocarbons means here? The organic compound which contains only carbon and hydrogen are called as hydrocarbons. The organic compounds which contains only carbon and hydrogen are called as hydrocarbons. Under the hydrocarbons, okay, hydrocarbons are they plays an important role in daily life. So without knowing us only, so they plays an important role in a daily life. So where we are using as a daily life means here hydrocarbons are they act as a fuels, petrol, diesel, kerosene, all those are the hydrocarbons only. Okay, at the same time some methane and at all some fuels also it is that in combustion reaction they releases more heat energy. Okay, so by using that heat energy we are doing some of the experiments. So okay, now hydrocarbons are they plays an important role in the daily life. Under the hydrocarbons we are going to study about alkanes, alkanes, alkenes, alkenes, alkynes, alkynes and aromatic compounds. Aromatic compounds. If we study aromatic compounds means 12th part almost all 30% they are covering under the aromatic compounds. Okay, so what are the concepts we are going to study under the hydrocarbons means alkanes, alkenes, alkynes and aromatic compounds. So today we are going to discuss about here alkanes. Okay, we are going to discuss about here alkane. So what is mean by the alkanes means here aliphatic saturated hydrocarbons are we can call it as a alkanes here. Aliphatic saturated hydrocarbons are called alkanes. Okay, sir, what is the saturated hydrocarbons means here? The compounds which contain carbon single bond is called as a saturated hydrocarbons. Okay, the compounds which contain here carbon single bond is called as a saturated hydrocarbons. Okay, so alkanes also we can call as a paraffins. Alkanes also we can call as a paraffin. Sir, what is meant by the paraffins means here? Paraffins are nothing but they are having less reactive. Okay, they are less reactive. Okay, and they are having the little affinity. Okay, paraffin is nothing but here para means little. Okay, affinity means they are having the little affinity. At normal temperature, they does not react with any other substances. Either it may be oxidizing agents, reducing agents are also okay. So they are not reacting with any other chemical substances. That is only we can call as here paraffins. So what is the general formula of the alkanes? The general formula of alkanes. So what is the general formula of the alkanes means here? One second. Here CN H2N plus 2. What is the general formula of the alkanes means here? Alkanes general formula is here CnH2n plus 2. So what is the simplest molecule of the alkane means CH4. Okay, so what is the simplest molecule of the alkane means here CH4. That is only we can call as a methane. So we have a different names for the methane. What are the different names we are having for the methane means here? Methane also we can call as a marsh gas. Okay, methane also we can call as a marsh gas, and this is also we can call as a fire damp. Okay, so fire damp also we can call. So marsh gas, fire damp. Okay, right now. So what are the other names of the methane means here? Methane also we can call as a marsh gas, and fire damp also we can call. Okay, excluding methane. So remaining other hydrocarbons are they containing carbon-carbon single bond. Excluding methane, others are they having here carbon-carbon single bond. Okay, now let us see the preparation of the alkenes. The preparation of the alkenes. Preparation. So what are the preparation of the alkenes? Preparation of alkane. So what are the, how you are going to prepare the alkanes means here? First of all, alkanes can be prepared from alkenes. Okay, from alkenes we are going to be prepared. From alkenes. Okay, from alkenes we are going to be prepared. For example, I am taking as a ethene, CH2 double bond CH2. CH2 double bond CH2. If the ethene is, it undergoes to the complete reduction reaction. So what are the reducing agents we are taking means here? Nickel, platinum, and palladium. So all these are, they act as a complete reducing agent. In this one, at room temperature, nickel it does not react here. At 300 Kelvin temperature only, nickel is going to be reacts. Okay, at 300 degrees or 300 Kelvin temperature here, nickel is, it undergoes to the reduction reaction and it converts the ethene into ethane. The molecular formula of the ethane is CH3 bond CH3. This we can call as here ethane. Okay, next. So what is the another reagents means here from alkynes? So what is the simplest alkyne means here? HC triple bond CH. So this we can call as a ethyne. Okay, this we can call as here ethane. If the ethine is, it undergoes to the complete reduction reaction also, it forms as a ethane. Okay, so how many hydrogen molecules we are going to be add means here? We are adding as a 2 moles of the hydrogen molecule. Sir, one hydrogen molecule is added by removal of the one pi bond. If you remove the one pi bond means, so both the carbon atoms are attached with the one hydrogen atom. So in between the carbon-carbon total, how many pi bonds are there? Means we have 2 pi bonds. That's why how many moles of the hydrogen we have to add means here, we have to add 2 moles of the hydrogen gas to convert the ethine into ethane. Okay, and from alcohols also we can prepare by here. Alkyl halides also we can prepare here from alkyl halide. So for example, CH3 bond, CH2 bond, Cl it is there. If it is reduced with zinc amalgam, okay, in presence of zinc, in presence of HCl, okay, or this also it is reduced with hydrogen iodide in presence of red phosphorus. Hydrogen iodide in presence of red phosphorus also, it is converted into ethane. Okay, and alcohol. From alcohol also we can prepare as a ethane. Okay. So what is the molecular formula means CH3 bond, CH2 bond, OH. If the ethyl alcohol is reduced with the hydrogen iodide in presence of red phosphorus, okay, hydrogen iodide in presence of red phosphorus also it is converted into ethane. Okay, and carboxylic acid, CH3 COOH. If the carboxylic acid also it is reduced with, so hydrogen iodide in presence of red phosphorus also is converted into ethane. I am taking one example. With one example, all reactions I am explaining. Okay, so because of this not the regular class to explain every reaction and to give us more number of examples here. Okay, Stigita? Okay, with
Yes,
one
sir.
example only I can explain all the reactions. Most whatever the reactions are there in the preparation of the alkanes, all that reactions we are going to be covered under this one only. If you go through this one means that is enough for you. Okay, it is the first revision here. Okay, now carboxylic acid also it is converted into ethane. Okay, and aldehyde functional groups are there. So what are the aldehyde means here? For example, acetaldehyde is there. CH3 CHO it is there. If the acetaldehyde is reduced with zinc amalgam in presence of HCl, this only we can call as a Clemmensen reducing agent. If the aldehydes are reduced with the Clemens and reducing agent means it is also converted into the ethane. Okay. Ketones also, so ketones also reduced into alkanes only. CH3 bond, C double bond O, bond CH3. Okay. Aldehydes and ketones also they converted into alkanes. Okay. Sir, other than this one, so we have some other reactions are there in the preparation of the alkanes. Sir, what are the other reactions? Which we have some named reactions are there. So by using that named reactions also we are going to prepare as a ethane. Sir, what are the named reactions we are having means here in this one? First one. So what is the first one means here? Urju reaction we are taking. Urju reaction. Which reaction ma? Urju reaction. Sir, what is mean by the Urju reaction means here? So when 2 moles of the alkyl halides, for example, I'm taking as a 2 moles of the ethyl chloride, C2H5Cl. If 2 moles of the ethyl chloride is treated with 2 moles of the sodium in presence of dry ether, to form as a symmetrical alkane. Okay, it forms as a symmetrical alkane. Symmetrical alkane means in reactant, how many carbon atoms are there? 2 are there. So in product total, how many carbon atoms you will get means you will get as a total 4 carbon atoms. 4 carbon atoms means it becomes as a butane. CH3 bond, CH2 bond, CH2 bond, CH3. Okay. Now, so by using the Urju reaction, so Urju reaction is one of the best method to synthesize the symmetrical alkanes. And by using this method, we cannot prepare as a methane. Okay, Urju reaction cannot be used for here preparation of the methane. And what is another condition means here? Urju reaction it always takes place in presence of dry ether. It is not possible to take place in presence of moisture condition. So it does not takes place in presence of moisture means sodium metal is highly reactive. It causes explosion with the water molecule. It causes explosion with the water molecule. So due to that reason only, Urju reaction does not takes place in presence of moisture. Got the clarity?
Yes, sir.
Okay. Now, okay. So what is the next one means here? Frank-Land reaction. Frank-Land reaction. Sir, what is meant with the Frank-Land reaction means here? It is also look like Urju reaction only. So here also we are taking as a 2 moles of the ethyl chloride. If 2 moles of the ethyl chloride is treated with, so 1 mole of the zinc in presence of dry ether. In presence of zinc in presence of dry ether means it forms as a butane. It forms as a butane plus ZnCl2 is going to be formed. It is also gives us a symmetrical alkanes. Okay, so we have a one method to prepare as unsymmetrical alkanes. So what is the method we are using to synthesize the unsymmetrical alkanes means here Corey-House synthesis. R-E-Y. Corey-House synthesis. Corey-House synthesis. So Corey-House synthesis is one of the best method to synthesize unsymmetrical alkanes. Okay, so which method is one of the best method to synthesize the unsymmetrical alkanes means here Corey-House synthesis is one of the best method to synthesize the unsymmetrical alkane. So first in this one, alkyl halide is so reacts with lithium. Okay, reacts with lithium. It forms as a alkyl halide. It forms as a alkyl lithium plus lithium chloride is going to be formed. Again, if 2 moles of the alkyl lithium is reacts with the cuprous chloride, it is reacts with here cuprous chloride. If it reacts with the cuprous chloride means it forms as a dialkyl lithium cuprate. Okay, so dialkyl lithium copper here. Dialkyl lithium copper metal only we can call it as a Gilman's reagent. This also we can call as a Gilman's reagent. Okay, again, whatever the Gilman's reagent it is that we are treating with another alkyl halide. That means another RX it is there. If it is treated with another mole of the alkyl halide means it forms as a unsymmetrical alkane plus alkyl lithium. Okay, alkyl copper plus lithium metal is going to be formed. Okay, so by using this method also we are going to be prepare as here unsymmetrical alkanes. Okay, sometime there is a question. So which of the following method is used to prepare as unsymmetrical alkanes? Which one is used to prepare as unsymmetrical alkanes, ma? Sriyuta?
Corey-House synthesis.
So which of the following methods are used to prepare as a symmetrical alkanes? Which of the following methods?
Wurtz reaction and Franklin reaction produce symmetrical.
Very good, ma. So Wurtz reaction and Franklin reactions are the give us here symmetrical alkanes. Okay, and another one is the decarboxylation reaction. Decarboxylation reaction. Sir, what is the decarboxylation reaction? Is removal of the carbon dioxide. Decarboxylation reaction is nothing but here removal of carbon dioxide. Sir, how we are going to do the decarboxylation reaction means when the sodium carboxylates are sodium carboxylates are treated with soda lime. Sodium carboxylates are treated with soda lime. For example, CH3COONA. If it is treated with the soda lime, sir, what is mean by the soda lime means it is a mixture of sodium hydroxide and calcium oxide mixture is called as a soda lime, and heat symbol. Soda lime. So calcium acetate, sodium acetate is treated with the soda lime. It is treated with the soda lime means it is converted into methane, CH4 plus Na2CO3. So by using the decarboxylation method, we can prepare as a methane. Which of the following method is used in the preparation of the methane means here decarboxylation reaction. Sir, how we are going to do the decarboxylation means here when the sodium carboxylates are treated with soda lime, they form as an alkane. Whatever the alkanes are formed, it has a one carbon atom less than that of the reactant. So in reactant, once you check it out, in reactant total we have 2 carbon atoms, but finally product, how many carbon atoms it is having means it has only 1 carbon atom. So product is having here only 1 carbon atom. So what is another method we are using means here coal-based electrolysis process. Coal-based electrolysis process. Sir, what is meant by the coal-based electrolysis process means here we are taking as a sodium carboxylate. Which one we are taking, ma? We are taking as a sodium carboxylate. For example, first we are taking as a CH3COONA. If the sodium carboxylates are sodium or potassium carboxylates are dissolved in a water, they undergo the ionization formation. So they are telling that electrolysis process. What is meant by the electrolysis process? 12th standard already we got electrochemistry also we studied. What is meant by the electrolysis process? Electrolysis process is nothing but it is the process decomposition of the chemical substance by passing the electric current is called as a electrolysis process. What is the electrolysis process, ma? Decomposition of the chemical substance by passing electric current is called as a electrolysis process. So after passing the electric current through the aqueous solution of the sodium acetate, it undergoes to the ionization form in the form of CH3COO minus plus Na plus. In electrolysis process means what happened? We are taking as a 2 electrodes. So one is called as a cathode. Cathode is having negative charge. Another one is it act as a anode. Anode is having positive charge. These 2 electrodes are connected to the battery by passing the electric current. So oppositely charged ions are moved towards to the oppositely charged electrode. At the same time, water also it undergoes to the ionization form means it forms as a H plus and OH minus ions. So H plus and OH minus ion at anode. So which reaction it takes place means here. So anode is having positive charge. That means negatively charged ions are moved towards to the anode. So which are the ions it is going to be moving here? OH minus ions and CH3COO minus ions are going to be most positively towards to the anode. At anode. So here which one is having the lower the discharge potential means CH3COO minus. CH3COO minus is loses 2 electrons. It loses here 2 electrons. Then it forms as a CH3COO radical and plus 2 electrons. We are taking as a 2 moles of the acetate. If we take 2 moles of the acetate means it loses 2 electrons. Then only it forms as a 2 moles of the free radical. Again, this free radical is it undergoes to the homolytic cleavage. It undergoes to the homolytic cleavage means it releases 2 moles of the carbon dioxide and it forms as a 2 methyl radicals. The 2 methyl radicals are combined together means they form as a symmetrical alkane. So by using the electrolysis method also, coal-based electrolysis method also, we can prepare as a symmetrical alkanes. Okay, and what is the reaction that takes place at cathode market? At anode, which gas is going to be released as means here, carbon dioxide here. Okay, so carbon dioxide gas is going to be released as at anode. At cathode, which gas is going to be released as means here once you checked out. So which ions are most towards to the cathode means Na plus ions, and H plus ions are most towards to the cathode. So which one is having the low discharge potential means hydrogen. Whatever the electrons it is releases at anode, that electrons are travel from anode to cathode. By reaching the cathode, these two H plus ions are gaining 2 electrons. After gaining up these 2 electrons, they form as a hydrogen gas. The releases here hydrogen gas. So hydrogen gas is releases at cathode. Okay, and carbon dioxide gas is releases at anode. The resulting solution is containing Na plus ions and OH minus ion. By combining together, they form as a NuOH. Hence, the resulting solution you will get as a basic solution. Got the point?
Yes, sir.
Right, ma'am. So what is another method we are using means here? So the next method is we are using for what is another method we are using means here? Next one is here Grignard reagent. Grignard reagent. So by using the Grignard reagent also we can prepare as an alkane. So first of all, what is mean by the Grignard reagent? What is mean by the Grignard reagent? What is mean by the Grignard reagent? So generally a Grignard reagent is nothing but RMGX. Okay, alkyl magnesium halide. Alkyl magnesium halide. Alkyl magnesium halide is called as a Grignard reagent. By using the Grignard reagent also we can prepare as a alkane. Sir, how are you going to prepare as a alkanes by using the Grignard reagent? Means, for example, I'm taking as a ethyl C2H5 MgBr, ethyl magnesium bromide. My ethyl magnesium bromide is treated with the water molecule, or it is treated with the ammonia, it is treated with the alcohol, it is treated with alcohol, it is treated with the carboxylic acid. Okay, carboxylic acid, any protic solvents. If ethyl magnesium bromide is treated with any protic solvents, we can call it as a protic solvent. Sir, what is meant by the protic solvent means which releases H plus ions, even acetylene, it's a C triple bond CH also. It is also acidic in nature. Okay, so when the Grignard reagent is treated with any protic solvent means it forms as a ethane. What is the product it forms here? It forms as a ethane. Sir, C2H5H6 is going to be formed, and byproduct is MgBr, and another one I'm writing as X. Sir, X is nothing but it may be OH minus, NH2, okay, OR group, COO group also, okay, and acetylene also it is there. So all these are the different methods we are using in the preparation of the alkanes. Now you got the clarity, ma?
Yes, sir.
Okay, next one. So what is the next concept we are having means here? Physical properties of the alkanes. Okay, physical properties of alkane. What are the physical properties of the alkanes? Physical properties. What are the physical properties of the alkanes we are having means here? Alkanes are colorless, odorless. Alkanes are colorless and odorless. Lower alkanes, between C1 to C4 are gases. C1 to C4 are gases. That means methane, ethane, propane, butane are here gases. Okay, and here, and C5 to C17 are liquids. C5 to C17 are liquids. Okay, then C18, greater than C18, whatever the hydrocarbons are there, all are waxy solids. Waxy solids. Okay, and they are insoluble in water. They are insoluble in water. They are highly soluble in organic solvents. So what are the examples of the organic solvent? Highly soluble in organic solvents. Organic solvent. So what are the examples of the organic solvents? Carbon disulfide, carbon trichloride, carbon disulfide, carbon tetrachloride, okay, and benzene, toluene, toluene. So all these are the examples of the organic solvent. So hydrocarbons are highly soluble in organic solvent. Okay, and so they're having low density while comparing with the water molecule. Hydrocarbons are having low density by comparing with water. Okay, so they're having low density than water. Okay, and boiling point temperatures, they have a low boiling point temperature, than water. Okay, so the boiling point temperatures are increases by increasing the carbon chain length. Boiling temperatures are increases by increasing carbon chain length and mass also. Okay, now here condition is that if branched chains are increases, branched chains are increases, boiling point temperature is going to be decreases. Okay, now you got the clarity, the branched chains are increases means boiling point temperatures are going to be decreases. Sir, what is the example for this one? Means here we have some structures. So what are the structures we are having? Means here, let us see. This we can call as a neopentane. Total how many carbon atoms are there here? 5 carbon atoms are there. So in this one, why we are calling as a neopentane means the last but one carbon atom is attaches with the 2 methyl groups. So that's why we can call it as a neopentane. Okay, and this we can call as a isopentane. Okay, and this we can call as here N-pentane. So which one is having the greater the boiling point temperature? Means N-pentane is having the greater the boiling point temperature while comparing with the neopentane and isopentane. So why the N-pentane is having the greater the boiling point temperature? Means two things are there. Okay, all carbon atoms are present in a straight line. When all carbon atoms are present in a straight line, surface area is going to be increases. Surface area is increases means van der Waals attraction forces are increases. Van der Waals attraction forces are increases means their boiling point temperature also is going to be increases. So due to that reason only, N-pentane is having high boiling point temperature while comparing with the neopentane, isopentane also. Clear? Okay, and here only I'm going to explain the primary, secondary, tertiary also. All terminal carbon atoms are we can call as a primary carbons. All terminals are we can call as a primary. If the carbon is attaches with the 2 neighboring carbon atoms, that we can call as a secondary. If the carbon is attaches with the neighboring 3 carbon atoms, is called as a tertiary. Sometimes they're asking the questions here. Okay, so what is the question they're asking? Means here, which hydrogen is more reactive in chemical properties? What is the reactivity order of the hydrogens in alkane? Tertiary hydrogen is more reactive than secondary. Secondary is more reactive than primary. Okay, sir, which we can call as a tertiary hydrogen means the hydrogen which is attaches with the tertiary carbon is called as a tertiary hydrogen. The hydrogens which are attaches to the secondary carbon is called as a secondary hydrogens. The hydrogens which are attaches to the primary carbon is called as a primary hydrogens. Okay, clear? In that also one more reason, here even number of the alkane which is having the even number of carbon atoms and odd number of carbon atoms. Which one is having the greater the boiling point temperature means? So the carbon which is the hydrocarbon which is having the even number of carbon atoms. Sir, why means here terminal carbons are present in opposite direction. So in a crystal lattice, we can accommodate more number of molecules. Number of molecules are increases. Their melting point temperature also is going to be increases. So which are having the high melting point temperature means here. So here, so the alkanes which are having even number of carbon atoms, they are having high melting point temperature than that of here. The alkanes which are having odd number of carbon atoms. In odd number of carbon atoms, terminals are present in the same direction, same side. they occupy the more space. If they occupy the more space means then crystal lattice, we can accommodate the less number of molecules. If you accommodate the less number of molecules means the melting point temperatures also is going to be decreases. Got it? All are the physical properties. Now we can take it out the chemical properties of the alkanes. Chemical properties of alkanes. Chemical properties. So what are the chemical properties of the alkanes? What are the chemical properties of the alkane? Actually, alkanes are less reactive at room temperature. Alkanes are less reactive at room temperature. They does not react with any chemical substances at room temperature. By changing the reaction condition only, they undergoes to the chemical reactions. In that one, what is the first reaction we are having means here? Halogens are it undergoes to the halogenation reaction. Halogenation reaction. Halogenation reaction. Halogenation reaction is example of free radical substitution reaction. It is example of here free radical substitution reaction. So what is the reactivity of the halogens towards the halogenation reaction means chlorine, and bromine and iodine. Okay, in this one, so chlorine reactivity with the fluorine is explosive here. Okay, so chlorine is more reactive, highly reactive. Okay, so bromine is low reactive. This one is iodine. Iodination reaction is very slow reaction. Very slow reaction. At the same time, iodination reaction is reversible reaction. Reversible reaction. Hence, the reaction is carried out in presence of strong acids. Strong acids. So what are the acids we are taking means here? HNO3 and HiO3 we are taking. Okay, so this in presence of strong acids only we are taking the iodination reaction. Otherwise, iodination reaction is reversible reaction. Okay, now what is the best example means methane. If the methane is it undergoes to the chlorination reaction in presence of sunlight or UV light or at high temperature. At high temperature means it forms as a mixture of products. That means methyl chloride, dichloromethane, okay, and CHCl3 and carbon tetrachloride CCl4. It gives us a mixture of product. Okay, so halogenation reaction it gives us a mixture of products. That's why it is not used in preparation of the haloalkanes in industrial sector. So why it is not used in the industrial sector means it is not possible to separate the mixture of products into individual products. Got it, ma?
Yes, sir.
Okay, so that is the one reaction. Okay, and what is the another reaction we are having means here? One is halogenation reaction, and here what are the other important reactions we are having means here? So next one is aromatization. Here isomerization reaction one it is that. So before that we will go for the combustion reaction. Before we will get to here combustion reaction. Sir, what is meant by the combustion reaction means here? If the hydrocarbons are heated in presence of oxygen, for example, methane it is there. If the methane gas is heated with the oxygen in presence of sunlight at high temperature, if it undergoes the combustion reaction means it forms as a carbon dioxide plus water molecule, 2 moles of the water molecule, and it releases high heat energy. Okay, so hydrocarbons are it undergoes to the combustion reaction. At the same time, hydrocarbons are it undergoes to the isomerization reaction. Isomerization reaction. Sir, what is meant by the isomerization reaction means here? If the alkenes are heated in presence of AlCl3. Okay, for example, I'm taking as a butane. So this we can call as a butane. Which butane means N-butane. This we can call as N-butane. If N-butane is heated in presence of AlCl3 and HCl, okay, in presence of AlCl3 and HCl at 300 Kelvin temperature, it undergoes to the isomerization and it forms as a isobutane. Forms as here isobutane. Okay, now it is converted from one structure to another structure is called as a isomerization reaction. Okay, now we got the clarity. And what is the another reaction we are having means here? Aromatization reaction. Aromatization reaction. Aromatization reaction. Okay. So to exhibit the aromatization reaction means hydrocarbon, it has to contain minimum 6 carbon atoms. Minimum how many carbon atoms are there here? It has to be 6 carbon atom. Okay. Now, if it undergoes to the aromatization, so that means, so hydrocarbon is heated with Cr2O3 and Al2O3 at 600 Kelvin temperature. By heating at 600 Kelvin temperature, sir, saturated hydrocarbon is converted into aromatic compound. This converted into aromatic compound. So this is also we can call as a hydrogenation reaction. Okay, so because of what we are doing in this one means we are removing the hydrogen molecules. We are removing here hydrogen molecules. Whenever you remove the hydrogen molecules, then only it forms as a double bond. So that's why this reaction also we can call it as a dehydrogenation reaction. Aromatization reaction also we can call it as a dehydrogenation reaction. By the aromatization reaction, we can convert the saturated hydrocarbons into aromatic compound. To exhibit the aromatization reaction, hydrocarbon, it has to contain minimum 6 carbon atoms. Minimum how many carbon atoms it has to be there here? It has minimum 6 carbon atoms it has to be there. Then only it exhibit as a aromatization reaction. Until that, it won't be exhibit as a aromatization reaction. Got it?
Yes, sir.
Okay. Next, pyrolysis reaction and cracking reaction also it is there. Pyrolysis. Sir, what is meant by the pyrolysis? Or this also we can call as a cracking reaction. Or this also we can call as a thermal decomposition. Thermal decomposition. Okay, this also we can call as a thermal decomposition. Sir, what is meant by the thermal decomposition, cracking and all means here? We can convert the high molecular mass substances into low molecular mass substances. Okay, by heating the hydrocarbons at high temperature, we can convert from high molecular mass substances into low molecular mass substances. So what is the example for that one means here? For example, I am taking as a butane. If the butane is heated at high temperature, butane is heated at high temperature. If it is heated at high temperature in presence of catalyst, in presence of catalyst means here, it may be formed as a propene and methane. It may be formed as a propene and methane. Or it may be formed as a 2 moles of the ethene, CH2 double bond, CH2 plus another one is it forms as a ethane, CH3 bond, CH3 also it is going to be formed. By using this method, we can prepare as a mixture of products. Okay, so what is meant by the cracking means or thermal decomposition means by using this method, we can convert high molecular mass substances into low molecular mass substances. Sir, how you are telling that means what is the molar mass of the butane? Any one of you? What is the molecular formula of the butane? Actually, C4H10. This we can call as a C4H10. C4H10 means what is the molar mass? C4 means 12 force 48 plus 10, 58. So what is the molar mass of the butane means 58. If it is methane means it is having 16 grams. So mass is decreases or increases? Decreases only now. So we can convert high molecular mass into low molecular mass substances are called as a pyrolysis or thermal decomposition reactions. All these are the preparations, physical properties and chemical properties of the hydrocarbons. Got it? Tomorrow?
Yes, sir.
Tomorrow we are going to discuss about alkenes and alkynes. If any possibility is there, both I am going to be completed by tomorrow. Actually, alkenes is a very big chapter. So many important reactions are there. Okay, if any possibility is that we'll complete simultaneously alkenes and alkynes. Okay?
Okay, sir.
Right, ma'am. So, but Sunday you're having exam based on the complete organic chemistry. Okay?
Yes, sir.
Right. So, I'll continue in the next class. Thank you,
Thank you,
ma'am.
sir.
Thank you all.